Okay, good evening, everyone. Kindly confirm whether you can hear me and see my screen, please. Send me a confirmation of the fact that you can hear me and you can as well see my screen, please. Oh, good evening. All right, thank you. Now, let me welcome you specially to the third week end of our lecture. We're already the third week today, so we are having just a week to go. And like I told you, today we shall be looking at offshore pricing theory. I forwarded the material to you then. I've forwarded the material. So without wasting our time, let me quickly go straight to the business of the day. We can commence the lecture in earnest. Okay, let us take the question one after the other. We already have the rules, so I don't need to go through those rules again in order to save time. Now, look at this question. The question says, suppose that the stock of SFM PSC is trading at 52 Naira, and there is a call option that trades on SFM with exercise price of 45 Naira, which expires in 3 months. The risk-free rate is 10% per annum, while the volatility is 15%. Okay, volatility is 15%. Required, compute the value of the call option and its corresponding put option. Compute the value of the call option and its corresponding put option. That is the question. Now, before we attempt to solve this question, it is necessary that we understand the concept of an option. Okay. Now, what is an option? Option, by definition, is a right that a holder of the option have to buy the underlying asset at the exercise price agreed in the option and at a future date with return for what? For a premium. That is the definition of an option. Okay, now let me clarify this. When we say someone has an option with respect to financial management, what we are simply saying is that that person has a particular right, and the right is the fact that he has entered into an agreement with another party that will enable that particular person that is the option holder to buy or sell an item at an exercise price in a future time. Now, let's take for instance, you want to buy, let me say, what's the popular item we use here? Let me say you intend to buy a cell phone, okay? You intend to buy a cell phone, perhaps for someone, okay? But presently, you don't have the money to buy that particular cell phone, but you are sure that you are going to get the money to buy that cell phone, say, in December. Now, your fear is that before December, the price of the cell phone must have gone up. If the price goes up, what does it mean? It means you have to buy in order to buy that cell phone, isn't it? Because of that, what you can do is that you can go to the seller of that cell phone and you tell him that, come, I need this phone in December. Okay? Now, but my fear is that the price will have gone up in December. Therefore, I want to buy an option so that you'll be able, you fix the price for me now, And that price you have fixed now is going to be the eventual price for which I am going to buy that particular cell phone in December. Okay, you can see when the price of the cell phone is fixed for you now, whatever happens to the price in December is no longer your concern, because you have already bought an option to what? To buy that phone at a predetermined price in December. Are we together? However, for you to have that right, you must have paid the price. And the price you paid is what we call the premium. You will have paid the option premium to the person selling that cell phone. Is that premium you have paid that is giving you the right to buy that cell phone in December at a predetermined price. Okay, that is what we call an option. Now, let me give you another example. Assuming your company is a type that normally gives Christmas bonuses to its members, its staff, okay? And then usually they give each employee a bag of rice, for instance, for Christmas. Now, we know how volatile the price of rice is, isn't it? Because of that, the company can say, okay, since we are buying like 1,000 bags of rice in December for as gift for our member. Now, if we want to wait until December before we buy this rice, the price will have gone up. Okay, what do we do? And we cannot buy it now and keep, because of what? Like is that they will contact a seller of rice. Okay, they contact a seller of rice and they tell that seller, come, we want to buy 1,000 bags of rice in December. Okay, but we want to fix the price now so that whatever happened to the price of rice in December, we will not be affected. The seller will fix the price. If the price for this, and the seller can say, okay, I'm fixing the price for you for 24,000 naira. Now, it means in December, when you want to buy that rice, you will buy the rice from that seller at the rate of 24,000 naira per bag. And for you to be able to exercise that right, you must have paid premium to that seller. Are we together? Okay, that being said, we have two types of option. We have what we call call option. We have what we call put option. When we talk of call option is the option that gives the holder the right, but not the obligation. Please take note, the right, but not the obligation to buy that particular underlying asset. On what? It can be shares. Okay, a call option gives the holder of that option the right to buy the underlying asset at a predetermined price in the future. Now, a put option, on the other hand, gives the right to the holder of that option to sell the underlying item in what? In a future time. It therefore means that if you want to sell a particular item in the future and you're fear that the price will have dropped, what can you do? You have to buy what? You have to buy what you call a put option from a person that want to buy that item from you. So when you buy the put option from the put option will entitle you to sell to that particular person from whom you have bought that put option. But if it is a call option, it means you want to buy that particular underlying asset in the future. Okay. Now, the price you pay, like I said earlier, the price you pay to acquire that option is what? Is the option premium. Okay. That option premium represents the value of the option. Okay. It represents the value of the option at the inception. Okay. At the inception means currently, as at when you enter into that option contract, the value of the option is the option premium. However, As the option approaches maturity, that is, this is September, right? And you have bought the option that you want to exercise in December. If the option price presently is 10 naira, for instance, as December approaches, the price might change from 10 naira. Okay, as the option expiry period approaches, the price of the option will change. It's either the option holder is gaining or the option holder is what? Is losing. Now, to compute the price of the option, we can use two ways in our computation. You can use what we call the binomial option pricing theory, which we are not going to cover here. We are not going to cover binomial. Now, the second one is what? You can use the Black-Scholes option pricing theory. That is the more popular option pricing. And that is the one ICANN has consistently tested in their exam, okay? That is why I'm focusing on Black-Scholes. The binomial, I've never come across it. It is in ICANN, I will not say it's not there, but I've never come across it in the ICANN exam. So I wouldn't want to also waste time on that. So, but the Black-Scholes is what we are going to what? Is what we are going to cover. Now, the Black-Scholes option pricing theory is used to calculate the value of a call option. Take note, the Black-Scholes option pricing theory is used to calculate the what? The value. The value of an option is also called the intrinsic value of an option. And what type of option? A call option, not for put. Take note, is used to calculate the intrinsic value of a call option. Are we together? Intrinsic value of a call option. Now, the formula for this is what we have here. I'm going to use this formula to explain what I want to explain to you. What do we have here? We have a C is equal to SO into ND1 minus E exponential minus RT into what? ND2. Now, this formula will be given to you in the exam, okay? This formula and this will be given to you in the exam. You don't really need this one. This one I highlighted here. You don't really need it, okay? You don't need it. I will tell you the reason why you don't need it, because it's going to be a long story if you want to be using that formula, okay? You don't need that. Don't bother yourself cramming that. The one you need to know how to apply is this and this, and other one that I'm going to show you later. Now, the C here represent call option price. Let me go there. The C here represent what? Call option price. The SO represent the current stock price. The stock means the underlying asset, which I've already told you it can be what? It can be shares. It can be a physical item, like physical item like commodities, okay? It can be crude oil, it can be wheat, it can be rice, it can be beans. So the underlying asset can be anything, whether visible or what, whether visible or what, or invisible, okay? Whether visible or invisible, okay? That particular item, that particular underlying asset, the current price is what is represented as SO. Please don't confuse C with S. C is the price of the option you are buying, the call option you are buying on that asset. The price of that option is what is represented by C, which is a call option. While SO is the current price of that particular item you want to buy in the future, not the option now, okay? Now, E is the exercise price. Okay, let me explain the exercise price. The exercise price is that price you are fixed with the seller now. Okay, you have fixed the price now, and that price will apply to that transaction in the future. So if you want to exercise your right, the price you are going to pay to buy that particular underlying asset is what we call the exercise price. The exercise price is used to buy the asset if you want to exercise your right. Don't forget, an option entitles you to what? To a right, but not obligation. You will only exercise your right if it is favorable to you. Let me give you an example. If, for instance, you have bought an option, a call option, that will enable you to buy a bag of rice in October. Let me say the exercise price of the rice was fixed as 25,000 naira. But eventually, in October, the price of rice is 23,000 naira. Please, you are going to respond to this. Let me come again. You bought that right. The right is that you will be able to buy a bag of rice at 25,000 naira in what? In October. But eventually in October, the price of rice is 23,000 naira. Please, are you going to exercise your right or not? Are you going to exercise your right? Let me see. Let me see your response. You have bought that right, that option that will enable you to buy a bag of rice for 25,000 naira. But eventually on that date, the price of rice is 23,000. Are you going to exercise that right? No. Yes, really. The answer is no. Why? Because if you want to exercise your right, you are going to pay more to buy that rice. Whereas in the open market, you can buy rice at all 23,000. So what do? You simply abandon that option. Okay, you simply abandon that option and you go to the open market and buy your rice at 23,000. But meanwhile, you are losing the premium you have already paid to buy that what? To buy that option. That is what you are going to lose. So anytime you are not exercising your right because the option is not favorable, you are losing your premium. The premium is not recoverable. Okay, the premium is not recoverable. Whether you are exercising your right or not, premium is paid. And premium is paid immediately the contract is formulated. Are we together? So that is what we call the exercise price. Okay, we now have, okay, before I go to, okay, I'm coming to that as well. I'm coming. You can see in that formula you have ND1 and ND2. That value is an estimate from where? From the normal distribution table. Please, sorry, I forget your normal distribution table. Please out, because that is what is the annual risk-free rate. The annual risk-free rate. The annual risk-free rate. That is our R. Okay, that is rate of return on what? On a risk-free investment. Then T. T is time to expiry of the option, and it has to be estimated as a proportion of year. If it is given in month, you have to convert it to year, okay, by dividing the number of months by what? By 12. Then we have volatility. That is our standard deviation. Volatility. The volatility is what? Is the changes in the what? In the value of the underlying asset. The degree of changes, it measures the degree of changes in the value of the underlying asset. We discussed volatility yesterday, if you could remember. Standard deviation, where I told you the standard deviation is what? Measures the what? Is a measure of dispersion. It's a measure of dispersion. That is the degree that your actual figure will be different from your estimated figure. Okay, that is what our standard deviation measure. Okay, it measures the degree of deviation of the current price of the underlying asset from what? From the actual price when the option matures. Okay, when the option matures. All right, these are the component of that formula. Okay, these are the component of that formula. Now, for you to use this formula, you need to start from somewhere. And from where do you start? You need to start from your D1, please. I'm not saying ND1. Look at what I highlighted here. D1, not ND1, please. The moment you put down this formula, the next thing you need to go and estimate is what? Is your D1. Okay? It's your D1. Now, how do you now estimate the D1? I've already explained the formula. This formula you are seeing here is what we call the Black-Scholes option pricing model. Okay? Black-Scholes option pricing model. That is the formula there. Now, how do you go about using this formula? Because what you just need to know is how to apply the formula, not you trying to what? Try to solve the cram the formula. Let me bring my calculator out. Okay, because I'm going to need it to put you through. All right. Now, you will see in, can you see in there? That in means natural logarithm. Are you with your calculator? If yes, look at your calculator. The second row, you know, the first row is where you have calc. The second row is where you have A, B over C. On that row, B over C, you will see in there. That in is representing natural logarithm. It's representing what? Natural logarithm. So it simply means that we are taking.
Go to right. I see left. And now you still go straight. Go straight. When you get to Ike Junction, then you now go towards.
Please let us all remember to mute our audios. You can see that there was a background there that disrupted our what? Our lecture. And don't forget, this lecture is being recorded, and when you have noise interference, you might not like the video when it is eventually released to you. That is why we often encourage everyone on this platform to mute their audios. Okay, and you can see it's one of our rules. Please check and make sure your audio and videos are what? Are muted. Okay, thank you. Let us continue. Now, I said it simply means that we are taking the logarithm of what? The current stock price all over what? The exercise price. So we are taking the log of that, natural logarithm. How do you do that? What you just need to do is pick your calculator, press that in where you have in, press in, and please remember to open bracket. You open bracket, put the stock market price, and put what? Divided by the exercise price, and close the bracket. Press or equal to. What comes out is the log of that what? Log of that number. Then we now say plus the risk-free rate plus 0.5 here is constant. 0.5 means half. In some question, in some textbook rather, you see it as variance over 2. You know variance is a standard deviation square. So square, if they give you variance, you don't need to square it again. Take note. These are minor things that can what? That can lead to issue in the exam. Look at the question. If what they give you is variance, you don't need to square it again. But if what they give is what? Is standard deviation, then you square the standard deviation and divide it by 2. You understand? So that is anything as well, square of standard deviation times 0.5. So add it to your risk-free rate, then multiply your result by t. Then come and divide it by root of time over times what? Standard deviation. That is the Black-Scholes option pricing model. Now, after you have gotten your D1, the next thing is to go and get your D2. After getting your D1, you need to go and get your D2. And how do you get your D2? D2 is computed as D1, the D1 that you computed here, is computed as D1 minus standard deviation times square root of t. T is your time to expiry of the option. Okay, so that will give you your D2. When you are done with D2, then you now need to go and calculate ND1 and ND2, which I'm going to show you how to calculate. Okay? Now, after calculating ND1 and ND2, just come to this place and substitute this. This one is what? This one you are seeing here is the same thing as present value of the exercise price. Okay? It's the same thing as the present value of the exercise price. It simply means that we are discounting our exercise price to what? To the present value. That's what it means. You know the exercise price is going to be in the future. So we are discounting it to what? To the present value equivalent. That is what that exponential function, that is what it represents. Okay, let us go and apply this to the formula. If I want to continue, if I want to explain everything on option pricing theory to you, I'm telling you, 3 days we are there explaining. So that is why I'm just cutting it and picking the important aspect that ICANN often test. Okay, these are what ICANN has been testing so long. Is what? Is this Black-Scholes, and that's why I'm explaining the component to you. All right, let us go and apply this to the question we have there. Suppose that the stock of SFM PSC is trading at 52 Naira, and there is a call option that trades on SFM with exercise price of 45 Naira, which expires in 3 months. The risk-free rate is 10% per annum, while the volatility is setting as what? Standard deviation. Volatility is setting as standard deviation. So while the volatility is 50%, compute the value of the call option and its corresponding put option. Okay, so the way you hear that, what do you need to go and do? Just go and pick your Black-Scholes option pricing formula. Pick your Black-Scholes option pricing formula. Look at it. I have the formula I gave you up there in, okay, let me go here and show you. This is my stock market price, Abby. Is it 62 or 52? Please, pardon. Let me check. Please, it's 52, not 62. Did I use 62 in the solution? Let me see. Okay, so please change it to 52. So we have 52 as the current price of the what? Of the underlying asset, isn't it? Then we have the exercise price is what? Is 45. Can you see that? Exercise price is 45. Now, forget about ND first. We are not there yet. The risk-free rate is what? 10%. The time to expiry is 3 months. Can you see that? I took the what? The equivalent amount in year. So 3/12. That is going to give me 0.25 years. So you have to express it in number of years, not month, please. Okay? Now, standard deviation is what? Is 15%. Standard deviation is 15%. And you now come here and put everything in that formula. In 52 over what? 45 plus this is my risk-free rate plus this 0.5 is constant multiplied by what? Variance, that is standard deviation square. Then multiply by 0.25 all over 0.15 times 0.25. I'm telling you again, this formula will be given in the what? In the exam. What you need to do is to know how to apply the formula. Okay. Now, when you evaluate this, pick your calculator, please. Pick your calculator. Locate in. Are we together? On your calculator, locate in. Okay. Have you located it? Just punch on that in. Then open your bracket. Okay. After open the bracket, put your what? 52 all over what? 45. Close the bracket and press equal to. What do you have? 0.1446 to 4 decimal places. Did you have the same thing? Let me see your response. Did you have the same thing? One thing is to know this. Another one is to know how to punch your calculator. If you don't know how to punch your calculator, then you will get it wrong. All right, thank you. Now, now say plus. I now come to this second part of the formula. This place, go and square will give me 0.0.5. You have 0.0113. 0.0113. Do you have that? Okay. Do you have 0.0113 here? You say no. How come? This is what I asked you to do. 0. You know you have to what? I know what, maybe what you did is that you multiply 0.5 by 0.15, I mean, it's not done. You have to follow your board man. That's why I'm taking my time to explain how to punch your calculator for this. Because it's not just you picking your calculator and punch it anyhow. Good, Ume, you can see 0.113, I mean. 0.0113, 0.15 square times 0.5 is 0.0113. Mr. Ume, please repunch your calculator again. Not 0.1113. It's 0.0113. Punch it correctly, please. I'm taking my time to explain this to you. When we go to our subsequent examples, I won't waste time like this. I'm using this out to explain this formula to you. So get it from here. I'm not going to waste time when we do the other example. Okay, now follow your board mass. If you follow your board mass, which one comes first? The one I highlighted here is 0.15. You need to square it first. So I will say 0.15 square will give me what? Did you get 0.0225? Let me see your response. Did you get 0.0225? Please, your response on time. Okay. Yes, okay. When you are done with that, then multiply your result by what? By 0.5. What did you have? 0.0113. Did you get it now? Did you get it now? Did you get it now, Mr. Okay, thank you. Then you will now come and add it to what? 0.1. I will now say 0.0113 plus 0.1. 0.0113 plus 0.1. That will give me what? 0.1113. Can you see that? 0.1113. Now, it is the whole thing now in this bracket is what? Is 0.1113. Is that one you are now going to multiply by what? Times 0.25. That gave me 0.0278, isn't it? 0.0278. Now, add it to 0.1146 plus 0.1446, I mean, 1446. I got 0.1724. Now divided by, when you multiply this is what I'm going to do. Take the square root of 0.25. Take the square root of 0.25, multiply by what? Is 0.15. What is the square root of 0.25? On your calculator, put on square root, then 0.25 equal to, what do you have? You have 0.5. You now say that's 0.5 times 0.15. That gives us what? Is 0.075. I believe we are following. Are we together, please? Are we together? Are we together? See, this topic we are treating tonight is what can give you 20 marks free of charge. Yes, it can give you 20 marks without you sweating. Yes, that is why I didn't want to skip it. Okay, that is why I didn't want to skip it. Go and look at ICAN questions consistently. There has never been any diet when offshore pricing theory was not set. No diet. So it's a repeated what? Repeated topic in ICAN. And that is why I said, no, I'm not going to skip this. Okay, even though we're not doing any other thing, this and edging, we are not going to skip them. Okay, so get it clear. Once you get it clear, you can solve it within 20 minutes and you get your 20 marks. In fact, even in less than 20 minutes, you can get your 20 marks. If you have 20 marks out of 50, you are left with what? 30. Isn't it? You are left with 30. In the remaining three questions, you should be able to get your 30 marks. Okay, let us continue. Now, add this to this and divide it by 0.075. What do I have? I have 2.299. 2.299. Okay, let me tell you this. When you get your D1, always approximate your value of D1 to 2 decimal places. That is, it is easier that way. Okay, it is easier that way. If you want to trace it from normal distribution table, okay, it is easier for you just if you just what approximate it to 2 decimal places. I believe we are together. It is easier for you to trace from the normal distribution table. Okay, let us continue. The moment you have gotten your D1, now go and get the value of your D2. How did I say you should get your D2? Your D2 is gotten as D1 minus standard deviation root of T. What can you notice about this? Who can tell me? What can you notice? The one I highlighted there. What can you notice about that? What can you notice? Your observation. Do we have auditors here? Okay. What observation can you see there? That one that I highlighted. What observation can you make with that regard? God bless you, Mr. Adam Yakub. God bless you abundantly. That is exactly what I wanted you people to say. It is the denominator of what? Of the D1 formula. Okay? So, if you have gotten this, do you need to go start wasting your time multiplying again? No. Just say, just bring this D1 here, not the one you approximated here. Don't use the one you approximated. Use the one you got here before approximation, bring it down, then deduct the denominator of a what? Of the formula of your D1. So that will give you what? 2.224 or what? 2.22. I told you the value of your D1 and D2 should be approximated to what? 2 decimal places. Okay? So now it is time for us to compute ND1 and ND2. At this juncture, I might need to stop sharing my screen so that I can go and open the formula so that I show you how to trace it. Now, before I go and share that formula, now, you need to know this. This is ND1, this is ND2, Abi. Both are found in the computation of what? In the computation of call option price. Can you see there? All what you are doing down there is to get our variable for what? For this formula. Is the variable for this formula that we are estimating. we have gotten our D1, but I don't need D1. I actually need what? ND1. We have gotten the value of D2, but I don't need only D2, but what? I need ND2. But for me to get ND1, I need to get my D1 first. For me to get ND2, I need to get my D2 first. Do you understand? So all what we are doing there is what? To get the variable for that formula. To get the variable for that formula. So after you have gotten your D1 and D2, look at the sign of the D1 and D2. Now, the first thing you are going to write ND1 is equal to 0.5, ND2 is equal to 0.5. This is 0.5 is 0.5. They are part of your formula. Yeah? It's a constant number there, please. Please don't chat me up and say, because I know I will receive chat that how did you get 0.5? I'm serious. If you chat me up on this, I'm not going to respond. Yes, I'm not going to respond because I'm saying it now loud and clear that I did not compute that what is 0.5. It's part of the formula for computing what? ND1 and ND2. Please don't chat me up and say, how did you get 0.5? I'm stressing it. Don't say, how did you get 0.5? Okay. Now, after you have put your 0.5 here, the next thing you need to look at, go and look for at your value of D1. Is it positive or negative? It's positive. If it is positive, come and put plus here. Go to the value of your D2. Is it positive or negative? If it is positive, put plus here. But if they had been negative figures, then you put minus. If the figure for your ND1 and ND2 are negative, this plus will be minus. If they are positive, the sign should be what? Should be plus. Do you understand? Do you understand that? Okay, correct. Yes, Mr. Ume, I mean, is it Mrs.? Sorry, see Mrs. Ume Joy. Is a constant in the formula. Is a constant in the formula. It's not calculated, okay? It's not calculated. It's a constant figure in the formula. Okay? Now, after you have decided whether this one is going to be plus or minus, which I've already told you the principle, then you now go back to your normal distribution table. You go to your normal distribution table. You go and trace this value. This 2.3, you trace it from the normal distribution table. 2.22, you trace it from the normal distribution table. How do you trace it? Let me go and share the screen for normal distribution table so that you see how this is traced. Please just help me remember. You know, I'm going to stop sharing this screen now, so I might not remember this 2.3 and 2.22. Please, I'm going to ask you the value of D1 and D2. Okay. Okay, let me stop this one first and go to where I will have to share the screen. Let me go and see. Give me just 2 minutes, please, to locate where we have that. Okay. Let me open one of the Pathfinder. Let me open one of the Pathfinder so that we can use that. One minute, please. One minute. One minute, please. Coming. Meeting. Wow. So I has no normal distribution table. And try to locate normal distribution table. This one does not have it. Okay. So a minute, please. I'm very sorry. I'm trying to look for. Okay, I think I should have here. So a minute, please. Let me see. Okay, thank God. I think I've seen. Okay. Standard normal distribution. Okay, good. Okay, I'm sharing my screen now so that you can see. I'm sharing my screen now. Standard normal distribution table. Okay, this is what we call your normal distribution table. Okay, these are what? Normal distribution table. Do you have one with you, please? Okay, do you have one with you? Make sure you have one with you so that you see what I'm going to do. The value of my D1 is what? Is 2.3, right? Is 2.3. Okay, what you are going to do is for you to pick the first two figures. Okay, the first two figures is going to be the whole number and what? And the first decimal. Please, are we together? Let me see your response. Are we together, please? Are we together or are we asleep? Okay, so in our value, in 2.30, which one is the first two figures? Which one is the first two figures? 2.3, right? 2.3 is the first two figures. So I will come to the horizontal here, okay? You go and trace where you have 2.3. You go and trace where you have 2.3. Look at it. See where I have my 2.3 here. This is where I have my 2.3, Abby. Okay. I have my 2.3 here. Now, after the 2.3, what values have we not used? You now consider the decimal part now. You know we have already used 3 because 3 is already here. So it means the figure remaining unused is what? 0.00. Do you understand? Is 0.00. We have already used 2.3. When you deduct 2.3 from 2.3, what is left? 0.00. Do you understand? So it means that you are going to trace 2.3 under what? Under 0.00, sorry. Under 0.00. Can you see that? This is my 0.00 and this is my what? And that's my 2.3. So what's the value there? The value is 0.4893. That is the value from the normal distribution table. Okay, then that is the value you are going to add to that 0.5. Okay, you add that value to 0.5. But if the value of your D1 is negative, you will have deducted what? You deduct this one from that 0.5. I believe the principle is clear now. Okay, what about the second one? Our D2. Our D2 is 2.2 what? Is it 2.24 or what? Let me see. What is the value of my D2, please? What's the value of D2? What's the value of D2? Okay, 2.22. Okay, thank you. 2.22. So what you are going to do is that you go and trace where you have 2.22. Look at it here. We have our 2.22 right here. We have okay, let me go with this. We have our 2.22 here. Now, sorry. These are 2.2, Abby. That's our 2.2. But the total value is not 2.2, but 2.22. So deduct 2.2 from 2.22. What do you have left? You have 0.02, Abby. You have 0.02. So you go and trace that 0.02 from what? From the number up here. From here, look at it, 0.02. So it means that you are going to trace 2.2 under 0.02, and that is giving me 0.4868. Is 0.4868. Before I close this, because I'm not coming to this again, I'll be asking you now, if we are solving other questions, to use your normal distribution table to get your figure. Okay. So, do we have any problem in arriving at our normal distribution, cumulative normal distribution value? Is there any challenge? Is there any difficulty before I close the chapter for that? Okay, your response is no, right? Okay. Let me continue then. So I stopped sharing back to my normal screen. Okay, so you can see that this is 0.4893. When you add it to 0.5, what do we have? Okay, thank you, Mrs. Woman. You have 0.9893. Okay, now come to NG2. The same thing, this plus that, you have 0.9868. Now, you are done. You have gotten the value that you are going to put in that formula. So now bring the formula. The formula is what? Is SO, look at my SO, current price of the underlying asset, right? Okay, times ND1, that is the value of my ND1, minus 42. What is my 42? Exercise price. Exercise, I told you, exponential of the exercise price, okay? So it's 42 to power what? 0.1. Please, I'm supposed to include exponential there, E, that's why it should be there. 42E raised to power minus 0.1 times 0.25. Let me go back to that formula and show you. Okay, look at what I'm saying here. Look at it, you have E. That capital letter E is the exercise price there. That small letter E is exponential. So it means exercise price exponential the risk-free rate times the time. But the risk-free rate we now carry what? We now carry negative sign because we are discounting. Okay? Is it 45 or 42? Are you serious? Oh, we are right. 45. Okay. Okay, just change it, please. Supposed to be 45. Okay. Sorry about that. Sorry about that. So you can change it and recompute it. Just understand what we are doing here. Then substitute the 45 for the exercise price. You get your figure. Just understand the procedure. Are we together? So we have our what? 42. It should be 45, like someone pointed it out. 42. Now, exponential minus the risk-free rate times the time to expiry. How do you go about this? Pick your calculator, please. Pick your calculator. Okay. Okay, let me do this based on that 40. Okay, let me use 42. You can do it in your note based on 45. Just correct it on your note. Okay, based on 45. Now, I will have, what I'm going to do is go and press your 42. I believe we are doing this now. Please, let's do it together. Let us do it together. Press your 42. Now, go and press your shift. That's the second function. Press your shift. After pressing your shift, go and look at where you have the button where it is written, not on the button, okay? You see E raised to power X. E raised to power X. Can you see that? Now, if you can see it, press it. That e raised to power x is exactly where you have that in. Do you understand? So what we're going to do is 42. When you press that 42, please give me, just spare me just 2 minutes to put on my gen, please. Just some minutes, please. Let me put on my gen. It is very dark, so I can continue with this. Thank you. I'm so sorry about that. I'll join you in 2 minutes. Okay. Sorry about the break, please. Okay, let us continue. I'm very sorry, please. I just needed to put on the gen. so that we can enjoy each other, one another. Now, I said you should press your what? Your 42, isn't it? 42. Then press your shift. Then go and press where you have that in. Where you have in, it serves the same function as what? As exponential. The moment you press your second function, it activates what? The exponential function. So just press the in. You see, E will come out on the calculator, isn't it? So open your bracket. Okay, open your bracket, then put minus 0.1, right? Then multiply by 0.25. Close the bracket. What do you have? What do you have? Let me see what you have. What do you have, please? 40.96, correct. 40.96, correct, correct. So that is how to go about it. The moment you don't put the word, the bracket, you are going to get a wrong figure. You are going to get a wrong figure. So it is very, very important that you put the word, you put the bracket and you put the minus there. Okay? So you now say times whatever figure you have got in here, multiply by what? By ND2. Multiply by ND2. So this will give us, this times this will give us 51.44 minus this times this will give us 40.42. Now, if it has to be, okay, let us change the exercise price to 45. You know, it was supposed to be 45. Mistakenly, I use what? I use 42. Let me use 45 instead. I will have 45 exponential, open bracket, minus 0.1 times 0.25, close bracket. I should have what? 43.89. Do we have the same thing? 43.89. Is that what we got? Is that what we got? Did you get that? Okay, good. 43.89. So I will simply say that 43.89, okay, subtracted from where? From 51.44. So what do I have? I have 7.55. Abi? Is that correct? 7.55 as the call offshore price. As the call offshore price. Okay? So that could have been the correct figure. You can adjust it later, please. You can adjust it later. Okay. Now, when you are done with the call offshore price, you know the question says you should calculate call offshore price and what? And the equivalent put offshore price. We have computed call offshore price. We are left with what? With put offshore price. Now, for you to compute put offshore price, normally, this is the formula you will have used. This formula here, this one here, this one with P, is the one you will have used. But for you to use this is another long process, which normally, even in study text, you won't see there. You will see this formula in icon text. Okay, so don't bother yourself cramming this formula because it's not what I'm going to use. Instead of me using this formula, the moment you know the price of a call option, the moment you know the price of a call option, you can calculate the price of an equivalent put option using what we call the put call parity. Okay, you can use the put call parity to calculate the price of an equivalent what? Put option. And how do we state the put call parity? The put call parity is a formula that establishes the theoretical relationship between a call option price and a put option price. Okay? It is a formula that explains what? The theoretical relationship between put option price and a call option price. It looks at the relationship between them. That's why it is called put call parity, PCP, put call parity, PCP. Now, the put call parity is stated here. This is the formula we call the put call parity. The put call parity will equally be given to you in the exam, okay? It will be given. It's not what you should cram as well. The put call parity will be given to you live and direct. You don't have to bother. You just have to know how to what? How to apply. Okay, the put call parity is telling you that the sum of call option price and the exercise price of the option is equal to the price of a put option plus the current price of the underlying assets. That is what put option put call parity is telling you that if you add the present value, if you add the present value of the underlying the present value of the exercise price, if you add it to the call option price, you should get exactly or approximately the same thing as what? As the put option price plus the current price of the underlying asset. Hence, if I know my call option price, I can what? I can make P the subject of the formula here and get my what? And get my put option price. That is why that formula is not the other one I said you should not bother about. That is why it is not used in practice. You can see this one question, I'm using to explain the whole what? The whole aspect of a Blasco to you. This is why it is taking me a very long time, okay? Now, let us continue. Making P the subject of the formula here, it means I have to transfer S to the other side, isn't it? So I will have my put price to be equal to call price plus present value of exercise price minus what? This I will change to minus the price of the underlying asset, minus the price of the underlying asset. So I will have put option price is equal to, what is the call option price? 11.02. I'm following what I did here, okay? You can follow your own, the correct one, 45 when you are done, no problem. Now, plus what? Plus the present value of the exercise price, okay? The one we computed before. I think it's okay, yeah, 40.96, Abby? Look at it here, 40.96. Then minus what? Minus 52. That is the price of the underlying asset. That gave me what? Approximately 0. So it means the put option price will be, the put will be what? Will be worthless. The put option will be worthless. So that is what the question wants you to do. Now, if you want to go with, by what we did, what we have there, I think the last one we completed was what? 43 point what? Let me see. I think you started me up on that. Let me see what you gave me then. 43.89. So let's see what I'm going to get. 43.89. So I can say 11.02 plus what? 11.02 plus 43.89, right? Minus what? Minus 52. So the put option price is supposed to be what? 2.91. 2.91, that is the put option price. Ladies and gentlemen, this is how to use Black-Scholes option pricing to estimate call option price and what? What is no, Mr. Adebesi? What is no? Is it not 43.89? Is it not correct? When you put 45 here instead of 42, I think we did it before. We got 43.89. Isn't it? Okay, I understand what I'm saying. Yeah, you are correct. Because what we got from here is what? Is different. Okay, you are correct. Yeah. Yeah, thank you. Thank you for that. You're correct. So it means you need to adjust this one as well. Okay, adjust this one as well. So when we adjusted, what did you get? What did you get? Call is 8.13. What about put? Is 0.019. Okay, 0.019. Okay, thank you. So that is the whole story behind Blasco's option pricing theory. This is a step to where we are going to. This is a step to where we are. If you don't know this, then you can't attempt icon question on offshore, okay? Because you need this. But you can see that the more you know this, it can take you more than 10 minutes for you to finish this one. Abi? Now let us go to the second question. An investor owns 1,200,000 shares of high-grade bank PSC stock. High-grade bank PSC stock currently selling for 50 naira. A call option on high-grade bank with a strike price of 40 naira is selling at 5 naira and has a delta of 0.6. I'm introducing new thing here, Nabi. Delta. Who is from Delta State here? Who is from Delta State? I know you will answer me now because I've mentioned the name of your state now. You will not answer me. We have a lot. I know you here. We have a lot of Delta people here. So we are back in your state now, Delta State. Now, required A, determine the number of call options necessary to create a delta neutral hedging. B, if instead of using call option, the investor decides to make use of put option, how many options will be needed? Okay, now, for you to solve this question, you must understand the concept of your delta. You must understand the concept of your delta. What does delta measure? Delta measures the changes in option price, whether call or put. It measures the changes in option price with respect to changes in the price of underlying assets. Okay? Don't forget, you buy option to be exercised in the future. Isn't it? Now, the value of the item for which we have bought an option, the price might either be increasing over towards the end of the expiry of the option, or it is decreasing. Isn't it? Okay. Now, as the price of that asset changes, so also the price of your option will be changing. That is what we call delta. The relationship between the magnitude of the changes between option price with respect to what changes in on price of the underlying asset is what we call delta. Okay, now we can use the concept of delta to hedge. We can use the concept of delta to what? To hedge. That is what we call delta neutral hedging. We call it delta neutral hedging. How do we do that? If I say I want to use my delta to hedge, what I'm saying is that I want to create a position such that whatever happens to the price of the asset is not going to affect my what? My option price. Let me come again. I said, as the price of the underlying asset changes, so also the what? The price of the option will also change, Abby. If you now want to hedge using delta, It means you want to create a position such that whatever happens to the price of the underlying asset, the price of the what? Of the option remains unchanged. That is what we call delta neutral hedging. Now, the delta of call, when you are dealing with call, the delta of call is ND1. Look at it. The ND1 we computed in that first question is our what? Is our delta of call. Okay. The common mistake students make is that because I have called ND1 as delta of call, they automatically take ND2 to mean delta of put. That is an erroneous application. ND1 is delta of call, but ND2 is not delta of put. How do we then compute delta of put? To compute delta of put, you have to deduct 1 from what? From ND1. So I can say delta of put is equal to ND1 minus 1. Delta of put is ND1 minus 1. Okay, look at in this question. We are already given our what? Our data, isn't it? We are already given our data. At DB, this data is not given. The question will have given me volatility. It will have given me time to expiry. It will have given me risk-free rate. If these are given to me, then the first thing that we need to compute is what? Is data. Before you can create a delta neutral hedging position, you must know your data. And for you to get your data, you make use of the Black-Scholes option pricing theory. Can you see the reason why I touched that formula first? And I did not, that is the reason why I did not jump to hedging. Okay? That is why I did not jump to hedging. So, for you to get your data that you are going to use for delta neutral hedging, you must estimate it from where? You must estimate that data from the Black-Scholes option pricing theory formula. But here, the moment data is given to you, please don't waste your time. Start to apply Black-Scholes. Black-Scholes is used to get data, and since data is given to you, what else do you want? You just use the data direct. That is why what I'm going to do here, look at it. What actually this bank wants to do is that the investor has what? 1,200 shares in this bank. It has 1,200 shares in this bank. And the share price is what? 50 naira. He does not want to sell the shares now. It means he wants to hold the shares. He doesn't want to sell the shares. Now, if he does not sell the shares now, there is every tendency that the price of the share will change, Abi. It's either the price has fallen or the price has what? Now, his fear is that the price will have what? Will have fallen. Therefore, he wants to hedge. And what does he want to use to hedge? He wants to use call to hedge. The investor wants to use call option to hedge. Is hedging against what? A fall in the market price of that share below what? Below the current price of what? 50. So if I want to calculate how many call option is needed and whether it's going to buy a call option or sell a call option, this is what I need to do. Look at it. I will go and create this table. Look at the table I will create. You will start with your what? With your security, quantity, delta, then total. That is the format. Now, what do I want to hedge? I want to hedge shares. Isn't it? I want to hedge shares. Shares remain my underlying asset. Okay, how many quantity of the shares I want to hedge? I want to hedge 1,200,000. Now, data of any underlying asset, please take note. Don't go and chat me again that how did I get 1? 1 is constant. The delta of the underlying asset is always 1. The delta of the underlying asset is 1. What is our underlying asset? Shares. So delta is 1. Anything underlying asset, the delta is what? Is always 1. So 1,200,000 times 1 is 1,200,000. Then what do I now want to use? I want to use call. I want to use call option. I want to use call option to hedge. How many units of call option do I need? I don't know. So I represent with what? With X. What is the delta of the call? The question says the delta of the call is what? The delta of the call is what? Is 0.6, isn't it? The delta of the call is 0.6. 1 minute, please. 1 minute, please. Okay, the data of the call as given in the question is what? Is 0.6. So multiply. Sorry, I think someone, is it that you have a question or what? Okay, let us continue. This is the delta of what? Of the call. Multiply the delta of the call by the number of call option needed. I got my what? 0.6x. That's how I got my 0.6 x. Okay. Okay. Now, after you have gotten this, you have gotten for the shares, you have gotten for the what? You have gotten for the call. Now you total the two. This plus this is going to give me what? This plus this is going to give me 1,200,000 plus what? Is 0.6x. Don't forget, I said our aim is that we want to create a position such that whatever happens to the price of what? Of the shares, Abi, is not going to affect the price of the call. Therefore, if I want to do that, I will need to set this. The total I have here, I will need to equate it to 0 because I don't want anything to what? To happen to the price of the call. So I equate it to 0. It means the changes in the price of the asset is not having any impact on the price of the call option. So plus 0.6x is equal to what? Make you have 0.6x is equal to this one now have what? We carry negative minus 100,000. Divide both sides by 0 what? Minus 2,000 call option. You therefore you will tell the examiner. You will tell the examiner that the investor, we need to what? We need to sell. Why did I say sell? The moment you get your figure and your figure is negative, it means the investor need to sell. But if the figure is positive, it means the investor need to buy. Okay, in this case, the investor need to what? Need to sell 2,000 units of call option in order to delta neutral hedge its position. Okay, the second requirement B is now telling us that if instead of a call option, if the investor has decided to use put option, what could have been your conclusion? Okay, the first thing is that I need to get the delta of put, Abi, because I want to use put option to hedge now, I need to get delta of put. And how do we get delta of put? Delta of put is equal to delta of call minus 1. So I have 0.6 minus 1. That is minus what? 0.4. Minus 0.4. So come and create the same table. Security remain the same thing. Now we are using put instead of call. How many put? I don't know. What is the data of put? Minus 0.4. Multiplied by the total put needed, x. I have minus 0.4x. I have minus what? 0.4x. So add the two together. I have 1,200,000 minus 0.4x. So I equate it to 0 as usual. Then I make x the subject. I have x is equal to, you know, this one is having minus. This one is also having minus. So minus over minus will change to plus. 1,200,000 divided by 0.4 will give me what? 3 million. And the figure is what? Positive, right? So the investor should buy because the figure is what? Is positive. So I will say, because this figure is positive, the company will need to buy, sorry, the investor, not company now. The investor will need to buy 3 million units of put option in order to hedge its position. Let me take your question here before I continue. Let me take your question before I continue. Let me take the question, your question before I continue. Any question, please? I'm waiting for your question before I continue. Obviously, I want to be able to even finish this today. We are still carrying it to Monday. We are still carrying it to Monday. Because we still have 3 questions to go. Still have 3 questions to go. Okay, let's go to question 3. If you don't have question, I go straight to question 3. You have sold short 155,000 units of ABBA PSC share. Call and put options exist on the company's shares. You are willing or put option is for the relevant options. You know that ND1 is equal to 0.38 required. Excuse me. How many call options are needed for data neutral hedging? And B, if put options are used, how many put options are needed? Now, let me explain this to you. When you hear sold or short, now, to take a short position, it means you want to sell. If you are taking a short position in shares, it means he has sold shares. But if I had said the investor has taken a long position in share, it means the investor has what? Has bought shares. So, because the client told me short position, then it means it's what? It's sell. My figure will carry negative. You don't forget, I said sell is negative, Abi. Buy is positive. The moment you hear short, then the figures will carry negative. And this is my data of what? Of call. So let's go to how we use the call to hedge. Now look at it. I have my security, my quantity, my data, and total. My shares, look at it, because it's short position. I'm taking a short position, I'm selling. So it has to be what? Minus 155,000. Then the data of underlying asset is always 1. Multiply it, we get this. Now, we are using call. How many call? I don't know. I represent it with what? With X. What is the data of call? 0.38. 0.38 times X. I have 0.38X. So add the two together. I have minus 155,000 plus 0.38X. Okay, so I will have minus 155,000 plus 0.38X is equal to 0. So when you transfer this to the other side, I have 0.38X is equal to 155,000. This will change to positive. Now, X is 155,000 over 0.38, which is what? 407,000 895 units. So the company we need to what? We need to buy. Where is it buying? Because this figure is positive. The company we need to what? We need to buy 407,895 units of call option to hedge its position. Okay. Now, you can see that all these are simple, and these are what I can test. Okay. These are what I can test. Please take note. You will see the last exam, I think May 2019. I have the question here. You see how simple the question was. Okay, you see how even though nasty assumption that we're not given to students. When we get there, I will explain to you. Okay. Now, if we want to use put option, the first thing is that we need to what? We need to compute the delta of what? The delta of put. Delta of put is equal to what? Delta of call minus what? Minus 1. So I'm having what? Minus 0.62. Now, my shares remain the same. Sorry, change this on to put. We haven't put a not call any longer. Not call. Not call is put. So the quantity is not known. This is the data. Multiply the data by the quantity. I have minus 0.62x. Add these two together. What do I have? Minus 155,000 minus 0.62x. Equate it to 0. So I have 0.62x is equal to 155,000. Then calculate the value of x, and that's giving me what? Minus 250,000. Because it is minus, I'm what? I'm selling. I will now say the company will need to sell 250,000 units of put option to hedge its position. Any question on this? You are not asking me question now. I'm asking you any question now. No one is asking question. Does it mean we perfectly understood? Does it mean we have perfectly understood it? Please let me know. You need to ask question if you don't understand. To ask question, you will see that option is simple. Option is simple. Okay, it's actually simple, and it can give you cheap mark on the exam. Perfectly understood. Okay, thank you, because I can give you 90% assurance, 90% assurance that you are going to have a question on offshore, Glasgow's offshore pricing theory. Okay, there's 90%. I'm not saying 100% too, so that if you go there and you are not see a question on offshore, you say and he said 100%. That's why I'm not saying 100%. What am I saying? I'm saying 90% assurance. It's a 90% assurance, not 100%. My host, please can you confirm whether you can hear me? Okay, students, can you confirm whether you can hear me here? Sorry, give me 1 minute, please. Trying to sort out something. Okay, let us continue. Let us continue. Question number 4. Let me see, can we finish this question before we run out of time? Let me see the magnitude of the question. If it's something we can quickly do so that we know that we are left with 5. Oh. We can't finish this question before we run out of time. Obviously, we can't. Okay, but we'll be able to, because I'm not going to. Let's take question 4. Let's take question 4. Let us take question 4. You are the finance director, FD of Faramola PSC, and your company has 250,000 shares in Olawale PSC, a major manufacturer of high-grade Nigerian wire. You are concerned about the recent volatility in Olawale's share price, which has made the future price difficult to predict with certainty. You therefore wish to protect your employer from possible losses which may arise as a result of a future fall in Olawale's share price, at least for the next 6 months, and do not wish to sell the shares at the moment. No dividend is expected on Olawale's shares over this period. Market data. Olawale's current share price, 250 kobo. Call option exercise price, 220 kobo. Time to expiry, 6 months. Interest rate, annual, 8%. Volatility of Olawale's share, 50% per year. Assume that option contracts are for the purchase or sale of unit of 1,000 shares. Devise a delta neutral hedge. Devise a delta hedge that is expected to protect the investment against changes in the price, in the share price, until the next 6 months. Okay, we want to delta neutral hedge as well in this question. Now, you will see that in this question, are we given data? No, we are not given data. Okay, now I want to delta neutral hedge. Is it call option that I need to use? Is it put option that I need to use? You see that the question did not tell you whether to use call option or to use put option. But look at the market data given to you. What can you see here? You can see call option exercise price, isn't it? You can see call option exercise price. Okay. We can see call option exercise price. Therefore, I'm using call option. I'm using call option. So the first thing I need to go and do is to go and compute delta of what? Delta of call. Because for you to delta neutral hedge, you need delta, isn't it? Okay, I need to go and compute delta of call. For you to compute delta of call, you need the Blasco option pricing formula. Blasco option pricing formula. So I need ND1. I don't even need this because I'm not computing price of what? Call. Am I computing price of call? No. So I don't need that formula. What I'm computing is ND1. So I can start from here. I can start from D1. I can start from D1. Now, the current share price is 250 kobo. Exercise price is 220. Risk-free rate is 8%. Volatility, please, this is volatility, not summation. It's standard deviation, 50%, not summation. Okay. I will go and put that in the Blasco option pricing formula. Blasco's option pricing formula. I have in 250 over exercise price plus risk-free rate plus 0.5 times 0.5 square times 0.5 over 0.5 root of what? Square root of 0.5. I told you I'm not going to waste time here again. I've already wasted a lot of time explaining that formula in question number 1. So press your in open bracket 250 over this, you should get 0. What? You get 0.1278 plus 0.08 plus do 0.5 squared times 0.5 you should get 0.125 times this. So this plus this multiplied by this is what is giving us this. Then square root of 0.5 times 0.5 is what is giving us this. Is 0.1278 plus 0.1025 is what is giving us is 0.2303. So divide this by that, you have your D1 to be 0.6513 or what? Or 0.65 or 0.65. Okay, I will now go to my normal distribution table. I go to my normal distribution table. Now, the figure for D1 is positive. So I will say my ND1 is equal to 0.5. Because this one is positive, I will add 0.5, I've told you, is constant, plus, because of the sign here, positive, so positive will be here. I will now go and trace what? Is 0.6 under 0.05. Is 0.6 under 0.05 will give me 0.2422. So when you add it to 0.5, I got 0.7422. So that's our delta of core. I will now go and establish my word delta neutral edge. You can see that before you can delta neutral edge, the starting point is for you to know your word, to know your data. Abi? Okay. So I have my security, I have quantity, I have data. We have shares. The number of shares is 250,000. Data of underlying asset is 1. Multiply this by this, you have 250,000. So I'm using core to edge. So how many core do I need? I don't know. I represent with what? With X. This is the data of core. Multiplied by this, what do I have? I have 0.7422 of X. Add the two together, you have this. Equate it to 0 to establish your delta position. So 0.7422X is equal to minus what? I'm transferring this to the other side. I have minus 250,000. Then find the value of X. I have X is equal to minus 250,000 over what? Is 0.7422. Now, there's something I need to do here that I did not do. Let me tell you. The question says, look at the instruction. I didn't use that instruction. Let me tell you how to use that instruction. Okay. Assume that option contracts are for what? The purchase or sale of unit of 1,000 shares. Meaning that one option we hedge what? One option we hedge 1,000 shares. So what I'm supposed to do is to divide the figure I got here. Okay, the figure I got here, I need to divide it by 1,000 because one option we hedge what? 1,000 shares. So I will have 836 over 1,000. So I need what? 300 and approximately 337 units of a call option. I need 337 units of call option. Okay, just divide it by 1,000. So, ladies and gentlemen, this is what we refer to as the Blaskow's option pricing model, and this is how to use option to hedge through what? Delta neutral hedging position. You can see that there is no big deal here, no big deal. Now, we have 2 questions. Okay, we have the question up to 6. Okay, we have 6 questions, not 5. Okay, if you see the last question, look at the last question. The last question is May 2019, question 5. May 2019, question 5. Very simple question if you understand the principle. Very simple question. And look at it. How many marks? 15 marks, Abi? Is it 15? Yes, 15 marks. 15 marks. And okay. So we might not be able to go further than this for today. We are going to drop the curtain of our lecture for today here. On Monday, we are going to treat the remaining 2 questions before we go to our hedging, which is currency risk and interest rate risk management. That's where we are going to start on Monday after we have completed this. And obviously, except we are able to finish that hedging on time, that might be our last topic. But if we're able to finish it on time, then I'm going to take bond valuation and analysis with you. I sincerely hope that I can take that topic because I'm highly suspecting it. So I just pray we'll be able to cover our hedging on time. If you're able to use Monday, Tuesday, and probably Thursday for our hedging, if you're able to complete it, then the last class on Friday, I'm going to take bond valuation with you by the grace of God. Okay, so do we have any question here before I call it a day here? Do you have any question? Do we have any question? Do we have any question? Question, I'm waiting. Question. I'm waiting for your question in the next 2 minutes before I call it a day. Waiting for you. Just 2 minutes. Okay. In the absence of any question, then let us call it a day on this platform. Thank you for staying with me for the lecture once again today, and do have a blissful night rest. Bye.